Welcome to lesson 64, a lesson on proportions. First thing is something that I've learned called the rule of three, la règle de trois. Tu as déjà vu ça. Tu sais que tu as un certain nombre de filles qui sont allées, de garçons qui sont allés à une fête dans une certaine année versus le nombre de filles. Puis on sait que la proportion est de 420 sur 400. Puis la question t'est posée, combien de filles faut-il inviter si on sait qu'il y a 525 garçons qui viennent pour avoir la même proportion de garçons et de filles. Alors, tu organises ton équation comme ça, 21 sur 20, 525 sur x, puis tu isoles x, et puis tu peux calculer la valeur de x. Alors, c'est assez simple. This is called a proportion. Proportion is an equation which states that two ratios are equal to each other. It's written either this way, a over b equals c over d, or as this way, a to b equals c to d. So the proportion of a to b is the same as the proportion of c to d. Here they introduce some things which are interesting. Means and extremes. So a over b equals c over d. If you have this, there are midpoints, I guess, and then there are extremes is the kind of idea here. Just turn the page. So basically it's simple. In the proportion a over b equals c over d, b and c are referred to as the means of the proportion, and a and d are referred to as the extremes of the proportion. So I guess it's just technical words, and I don't think they do a really good job here explaining what means and extremes mean, because if you invert them, if you say c over d equals a over b, then which are the means and which are the extremes? They're switched, aren't they? So I'm not sure what that means exactly. The geometric mean, however, is interesting. This is a form of an average that we use at work. Basically, if you're taking, get a piece of paper here. There's an average I think you're familiar with, where you say the average of let's say 2 and 6, the average, you sum if you want the average of those two numbers, you add them together and you divide by 2, and you'll get 8 divided by 2 equals 4, and you'll say the average is 4. That's not the only way to calculate an average. That's called an arithmetic average. There's also something called a geometric average. And the geometric average of 2 and 6 is equal to 2 times 6 to the square root. So 2 times 6 equals 12. Whoops, I can't write when I'm filming myself. And the square root of 12 will give you some number which multiplied by itself gives you 12. So what would that be? It's somewhere between 3 and 4. We'll call it 3 point something. Okay, and you can calculate it on your calculator. Note it's not equal to 4, not the same value. So the geomean is not the same thing as an arithmetic mean, but it's another way of calculating a centered value between 2 points. Of course, geomeans can be expanded to an infinite number of values. Same thing as an arithmetic mean. An arithmetic mean can be a sum of 3 numbers, 2 plus 6 plus 7, in which case you divide by 3. So the divisor, the denominator, is always the same as the count of the terms you're finding an average of. For the geomean, it's the same thing. It might be 2 times 6 times 7 raised to the square root here, this way. Okay? Or equivalently, 2 times 6 times 7 in brackets 1/3. And that's the cubic root of that. And if there are n terms, then it's 1 over n. And you can punch this into any scientific calculator. So you multiply them by each other and take the nth root, and you get the geomean. So that's explained a little bit differently in your text, and in an interesting way, a way I'd never seen before. They say if you have these proportions, 18 over 6 and 6 over 2, because the mean points are the same, so it's b and the c term or it's actually B rather, are the same, then B is said to be the geometric mean. And if you isolate 6, if you multiply through, we do 6 times 6 and 2 times 18, you have 36 equals 36, obviously. And how do they show it here? Yeah, interestingly, the geomean of two numbers can be calculated without setting up a proportion. We know the arithmetic mean, as I was just explaining to you. To calculate a geometric mean of two numbers, we multiply the numbers and take the square root of that result. So to get geomean of 18 and 2, which we already know is 6, we first multiply 18 by 2, and then we take the, instead of dividing by 2, we find the square root, and that equals 6. So that was a longish segment on the geometric mean, but I just found it, it's an interesting mean, and it shows that it's not the only way of calculating a mean or an average. That the arithmetic mean, rather, is not the only way. Cross multiplying, this is a very basic notion. When you have a proportion, you multiply the two extremes and the two means, and so you multiply through by b, and you end up with AD equals BC. So I don't think this is new or mysterious for you, but again, they show you how that can be done. And there's a theorem in a proportion. The product of the means is equal to the product of the extremes. Of course, that should be obvious if you take the time to read it through. And finally, flipping it over, in case you didn't know, you can invert both terms in a proportion and the equality still stands. So 3 over 12 equals 1/4 can be flipped over. The numbers can be flipped to 12 over 3 equals 4 over 1, obviously. This is 4 times the size of this, and so is this with respect to this. So it still stands, and that's obvious. So a longish lesson, but not a very difficult lesson. They say it's a tough lesson. I don't think it is, but it's a bit longer, and there's a bunch of notions there, and it's a bit fiddly, I guess. So just read it carefully, and good luck with the exercises. Bye.